Hello, this is Paul, and this is another weekly live stream where I work on Mythruna a little bit and we push the progress around. You notice in the bottom of the screen there, I've put the test engine build. That's where you can download the January release. It'll also be in the upper left corner when we get started. But I thought I'd make it a little more prominent so people don't have to hunt around as much. Tonight we're going to be working on like chopping blocks into like sub parts and stuff for when we hit it with tools versus just making them disappear with the wand. Before we get too much farther, let's go and thank the patrons. Since the American healthcare industry is doing its best to bankrupt me, I really appreciate the contributions that you all make. So thanks a lot. And let us get started. And in the upper left corner, again, through the whole video, that'll be there. That's the test engine build up there. Go there. That's also where you can join the Discord if you are not already a member of the Discord. And you can chat with fellow Mythrunians any time of day. Alright, let me go ahead and move this out of the way and we'll get started. As usual, before I get too far, I'm going to go over what I got done since last time. Basically, I finalized what I want to do with the AI for this release. I'm still trying to put a release out by the end of the month, but the end of the month is looking like maybe like April 1st. We'll see. It depends on how productive I am this weekend, but it looks like it's going to rain tonight and tomorrow, which means that I will be stuck inside all day. Maybe I'll get a lot done. We'll see. Anyway, let me show you the AI work that I did, finished up last weekend. We can see the things interact. If you are new to the live stream, welcome. Consider subscribing if you're not already subscribed. And you will get notifications, especially if you click the little bell icon and then click the little thing that says, yes, I'm really sure that I want notifications. Or if you're on the Discord, I notify everybody there too. And I'm on the usual places, Twitter, Blue Sky, etc. All of which are in the description link of this video. Okay, so let me make this a light setting that you can see. Yeah, here I was making my sample image, which I made out of a block object, just to give something that I could put in the thumbnail. But okay, let me do the test wand, and we'll put some things around. So we've got our NPCs doing their little thing. If we place the Gafen down, yeah, so when they see themselves moving fast, they say coo. And when we move up close to them, we move too fast, so they run away from us. And so similarly, if we place a dog, he'll come up to us. We let us set his home, and he'll wander around. Anything he sees, he'll go running up to, or she, whatever. And so sometimes that makes the chickens or the Gafen get chased. Yeah, see, chasing them away. The thumbnail was a lie, a bit. That's where I want to get to. I wish I had made it that far. So, anyway, the dog's chasing the Gafen around. It has a memory of like 5 minutes. If it sees somebody new after that, it remembers for 5 minutes who's new and who's not. Yeah, so we've got, and if you pet the dog, oops, he should come running after me. Yeah, so the dog then chases us around, so he comes following for 20 seconds or something. Yeah, so then we can chase the chickens together, or chase the Gafen together. So yeah, that's pretty cool. The butterfly are still there. They do their thing. Which is kind of random walk. They kind of like fall out of the sky, but they do it slowly. But anyway, it's kind of a little life in the game. I still have to hook up the random encounters that make this, make the butterflies happen, and I want to add some. When I plop the town NPC down, I want to like randomly give them a dog, and maybe plop a few Gafen down in the town just to wander around. Every time there's a dog, I'll probably try to put some Gaphin in there. So we'll set up some random encounters before the release. But yeah, as to my lie over here, I basically fashioned that as it. Basically, this is exactly how it's going to work, though. When we start chopping a block, the block will get replaced with the equivalent of an object. They won't exactly be objects. The game will still think it's a block there, but basically the rendering will be of these smaller block types. What we're going to be working on tonight, though, is sort of being able to know that since I'm in the game already, we'll do it from here, and I can talk about what the build one will mean versus the tools. So if we have a stone, so a stone cube sitting right here, and I were to like chop this corner with my axe, my pickaxe, and hard enough to actually chip that away, what I would like to do is be able to search all of the block shapes for stone and find the closest match, which I imagine will be the wide wedge, but I mean I can't be sure until I actually implement this. But what I imagine to be, once you've chipped that away, that this would be the closest shape that would get rid of that particular corner. And it could be that we have to chip farther away or further down to make that happen. But what I want to be able to do is, given this shape and the fact that I want to remove this corner, find the best shape to replace it with. And while so that's interesting. Why did you walk through this block? Oh, I know why. Because the collision shapes for this particular orientation of block are broken. You see, I fall right through the world. I'm glad that the doggy didn't, so let me remove that before it's a problem. That's a known bug, and it's actually going to cause me a problem when I go to do this stuff. Why is this spinning away? Anyway. Where was I? Oh, yeah, so while I'm talking about big blocks, where I want this to take place is in the little blocks. So if I actually chop this, I want to basically, there'll be a more granular chopping system. So if I chop this part of the block, I need to know that I removed that part, and that this is the closest shape that would replace it. Or if I chop this, I know that this is the closest shape that would replace it. And then the larger scale, so let me try to explain what I'm talking about. So if you have a block, why does it always unselect my pen? So if you have a block here and you hit it with the tool here, right? I know I need to remove this block. But depending on where you hit it, I might remove it and replace it with one of the wedge blocks, or I might remove it and place it with a slab, or so that's that. Being able to search for the nearest shape that represents that particular chopped away block is useful for that. But the other interesting thing is, so if I know I've already chopped this block away and this block away and this block away, and if I want to come up with the closest representation for this block that has all those open, it's the same problem. Because what I'd really like to do is, even though I'm rendering a thing like this as an object, I would like to also place this block down, or whatever the closest shape is, that I put this on top of, so that when you're far away and that object disappears, or so that the lighting still works correctly, so light doesn't propagate through here, even though this is not a solid object, but light might propagate through this way, right? And so so there are similar problems, and so what we end up having to do is come up with a way of, given this shape, and I want to take away this part, how do I find, the closest match, whatever that would be, of the existing block shapes. And what I have done, and so why are we doing this, right? Um, there's going to be two ways to get rid of blocks in Mythruna. One is to use the build wand, which is the one we already have, right? Where I can just go and I can say, yeah, I don't want dirt there anymore. Click, it's gone. And you'll get resources for that, but they'll be sort of base resources or substances, as I'm calling them in my design. So when you take one of these grass blocks away, it'll fill your meters with some number of dirt, some trace stone of various varieties, and some organic matter, however I choose to define that. Just like if you got rid of one of these, you get some amount of organic matter loaded up into your wand, which will have your wand will have some kind of counters on how many base materials it's collecting, and then you can use that to place. You can use your build wand then to place other blocks around. Hey, you guys are stuck. To place other blocks around. So you couldn't place stone unless you had collected enough, stone material, that kind of thing. So no inventory, but there probably will be, different qualities of wands that can hold, different capacity of all the different kinds of things. But the idea being, if you looked at this wand, maybe you'll get little meters showing you all the different substances it's holding, and in here it would show you what you can place, that kind of thing. And then if you actually, so like say we have stone here, we're mining. If I nuke this with my wand, all I get out of it is the base substances. If I wanted to mine for gems or, rare ores or something like that, that's when I'd have to get my tool out and chop it up. So that's when I have to get it out and start chopping pieces off, because that's when the prospecting happens, right? As I chop chunks off, maybe I find little bits of copper, or I don't know if copper will be that rare, emeralds or whatever little bits of gems that might be in this rock, and that lets certain characters be able to, like dwarves and stuff, might have sort of a nose for what things might be in different kind of rocks. They might look different to them. I don't know how that's going to work exactly, but the idea being that you chip it away and then you get the raw materials from that, and they'll just fall on the ground and you can pick them up. They're not going to be stored in your build wand. They'll be actual part of the inventory. And while you are a magical being that can use a build wand, NPCs, when they build, when they chop down trees, when they mine, they got to do it the old-fashioned way with tools. So if you have a bunch of NPCs digging a mine looking for stuff and you walk away for a month and you come back, that mine's not going to be very far, because it's going to take them forever to chip away blocks like this, right? That sort of thing. Anyway, I think that's how I balance the unlimited inventory that's in your build wand versus actually having to do work for certain kinds of activities, and to make that harder rather than harder in a like maybe more fun way than just nuking swaths and swaths of underground tunnels just to find one diamond. So anyway, but that'll be an experiment. Getting this to work is kind of what we're talking about today, though. But that's the why and the where. I wanted to be able. One of the things I really hated in the other Block World game was, the fact that just to get around and do stuff and build, you end up collecting, tons and tons of stone. And realistically, 1 cubic meter of stone is more stone than any human could ever carry, let alone a stack of 64 of them, right? And so Mythruna gets around that by calling it magic, and it puts it in your build wand. And if you chopped up this stone into a bunch of rocks, then you have to start dealing with the inventory problems. Or you clean them up with your build wand, and then you lose all the crap, but you get the material that you can use to build stuff later. So it's kind of an experiment to see how that goes. But I really hated just when I wanted to build something in that other game, I had to go back to my chests where I stored all the crap that I just got collaterally when I was digging tunnels and stuff, and I don't like that idea. I think as I'm digging tunnels and I'm just collecting stuff, I'm just de-resing it, right? I should just have that somewhere that I can draw from. with maybe not as much limitations as, anyway, we'll see what the balance is, but that's what we're working on tonight, and I'm glad you're hyped for it, Ron. I saw that earlier. So anyway, so what I've done so far, and this is the more experimental part of what I'm talking about, is if we run the shaper tool, we can see what I've been doing. So what I believe is that I can turn a block into a 4x4x4 grid of bits. And if they're on, that's solid. If they're off, so let me change this to a post or something so we see what I'm talking about. So if we change this to a post, you can see the red ones are places where there is no block, and the blue are places where there is a block. And why 4x4x4 is a nice quantity, in addition to just being a sort of decent subdivision. It also lines up with our current block object subdivision, by the way. But also 4 times 4 times 4 is 64, and so I could represent all of this in one value of bits on and off. In fact, that's what I'm doing. If I go run a script, I can actually show you, like if you execute the script for each of the shapes, you get what their bit signature was. So for a wedge, you get like these bits. There are 40 of them on, don't have to worry about that. And here's where you can see there's a bug. So the wide wedges, 2 of the directions work fine, 2 of the directions do not. They come back with 0, basically no collisions. So that's something I have to fix. Wide wedges are busted. I think narrow wedges might be as well. I've still not implemented colliders for the corners yet. That's going to come back and bite me. So part of the reason I'm tentative about whether I can get a release out on the 1st is because I may get into this week and I may find, yeah, everything works. And then normally I'd use another week to kind of wrap that up and integrate it. But it could be that it works, but I'm going to start hitting a limitation with these colliders that are broken or unimplemented, and those are very tedious to write, and they may take me a little more time, and it might be worth just tackling those. Yeah, so cubes are all solid, right? The other thing, while I was talking about limitations. What was the other thing I was going to say? Let me think. So we have to do the experiment and see if it works. And so what I was going to do tonight, so even if I don't get the sub-block part in, if I at least got the fact that if you chop a corner out, it could change to this block, even in the regular block type, that would be at least a progress in the right direction, right? So even if I can't get the, like in the, in my screenshot, even if I can't get that working for this release, the partway there part still gets us pretty close to be able to chop a piece of the stone off and have it change the block to a different shape. That would be pretty cool on its own. So I may just cut it off, but I do think I'm going to have to fix these colliders that are broken. But we'll see. So anyway, this creates a bit signature, and then so in theory, I could look for similar bit signatures that were close. We also want to be careful that it doesn't add bits. So in this case, if I was to chop one of these off, the only closest other signature would be nothing, because none of the other blocks are this shape with just part of this missing. And you don't want to add shapes back. So while a corner shape, if it worked, a wedge corner, if I chop this off, a wedge corner might be closer, if you just counted the bits that are in common. We don't want to expand the number of bits that are on, because it would look weird to chop this off and have the block get bigger. So that's the tricky part, and that's the parts where I worry that this whole approach won't work. But the nice thing is that I believe the infrastructure that I have to set up to look for one block from another block shape if you remove this little part, all of that holds, even if I can't cheat and use bit masks to do it. I could always use more conventional means to find similar shapes, or hard code it all. There's only 70 different shapes right now. So Anyway, so yeah, I was building like this similar shape index, and what we need is a way to test this. And so what I thought we could do is add some tools to Blockhead, because that would be pretty neat. And Blockhead sets us up to, is your bit storage similar to how ECC checks for damaged data? I mean, not really. It's just basically if the bit's on, I turn it, if the collision's on, I turn it off. So, you know, in a 4x4 grid, you know, it's just like a 4x4 array in a sense where you calculate the index by, you know, x multiplied by 16 plus y multiplied by 4 plus z kind of thing. And then you turn that bit on and off. So what I thought was in the Blockhead tool here, I could make a different kind of tool that was like a little chopper tool that would deal with sub-blocks, and if we removed one of those, then it would find the best shape. And so I'd add another tool row here. Actually, Blockhead, this is what we really want is Blockhead 2. I forget that I had an old one that I wrote for my kids. And Blockhead 2 is much more advanced. Anyway, what I would like to get done tonight is to have the other tool bar written that has the chopper tools, and then I would like to hook that up to find similar signatures. I think if we can get that done, that sets me up for the weekend. Hopefully I don't get wrapped around the axle with UI related issues. But this is the Blockhead tool. I'm pretty sure I've showed this before. But you know, if we have like this big thing, we want to be able to, you know, if I chop this one away, what's the next best shape that would match that? And I think base 0 has all the shapes. Oh, yeah. The nice thing about here is we get to see the shapes separately. Oh, nope, base 0 only has cubes. We might end up wanting to use the actual Mythruna shapes for this, because Mythruna has more shapes than the Blockhead tool. Though that could make it easier to debug. So if we had base 1 and I knew we could find the wedge, I don't think, which one's, I think it's the all that has the, oh yeah, so this is the one that has all of the different shapes. It's just an ugly, it's the texture with every color on it. Anyway, so let's get started. I need to relearn where these tool icons come from, and we're going to, yeah, I think I can just add a fourth one. I don't need a whole other row. Although eventually I want to test both things. So first we're going to make a version that if I click, you know, part of this, you know, it will find the other block. And then I want another version that deals with these, you know, 4x4 cubes, because, you know, if you click here or here or here, you know, you want to remove both of these and replace them with some sub blocks. And so I want two tools, one that works on the single block level, one that works on the multi-block level. But today I'm just going to concentrate on the single block level. All right. I hope you all had a great week. My week was not so great. Just very, very busy. I was upset I didn't get to work on Mythruna much. Alrighty. But I guess being busy is okay, better, I guess, than being bored. I don't know. Where to start? Let's see. I need to actually open the Blockhead stuff. Okay, so there's the build. I like to open the build because it helps me keep track of all the things I've got open. Okay, so first we will find main, then we will find the tool panel state, and I think I made the tools Yeah, tools. So there's a special kind of tool interface, which is good. That's perfect for us. And we want to So yeah, it looks like I have all the details I would need passed to these methods. Does it? Yeah, it even has its own cursor. That's good. And it sets up its own. No, that's the X block. Who creates the icon? Tool buttons. Okay, so when we create the tool down here somewhere, yeah, we set up a button. Okay, so we are going to make a chopper tool. Yeah, so get block location world position. So I think I can. Okay, so let's make a chopper tool mini chop tool. Alright, so actually keep this. Take this. Yeah, I hesitate to put this as part of Blocked 2 is part of the open source tool suite. I hesitate to put this as part of that, but I can sort that out later. Oh, it doesn't have a logger. I hadn't added that to my template before. Okay. Oh, yes, it's all good. Sorry, doing cut and paste coding here, which always exciting. Trying to think what I want. I don't need any block types. I do want to keep these for a minute. Do all the tools get a block type? I didn't put @overrides on these, so I don't know what. So set block type, which we don't want to do anything for. We don't care. And so these, I don't believe that's part of the tool. Yeah. So I don't think we need it. And all these are good. We don't need anything for add. We do want to do stuff for remove, and we don't need anything for combo. So I'm going to log alternate blocks world pos. Oh, good. It tells me normal too. Okay, we're going to see what we get out of that. And then I'm going to replace the cursor at some point. But the thing is, they don't let me place the cursor, do they? Oh yeah, I get to make my own cursor. Okay, cool. So I can make even a mini cursor or a little chopper thing or something. So let's make that an X. Select mini chopper. Okay, let's make it a little X. And then we don't need to set an icon for it because I don't I'm not going to create an icon on the live stream. That would just probably bore you guys to tears. So tool buttons 4, index 4. Yeah, those are all fine. Refresh tool. I think everything just works except that I need to make this, wherever that is, I need to make another one that's protected. Void set mini chopper. Did I call it mini chopper tool? Nope. But I will to be consistent. Mini chopper tool. Tool index equals 4. Refresh tool. So if I've done this right, we've gotten the boring stuff out of the way. Well, it's all relative. Ooh, yuck. Okay, so whenever you get a whole stream of errors like that, you go to the top, because basically it seems like somebody forgot a curly brace somewhere. Yeah. Mini chop tool. Oh. Okay, so line 66. I didn't name it. Mini chop tool. Didn't change the constructor. Okay. And that may have caused the other to fail. If it can't find the class. Oh, I forgot a comma. It's another common thing in these. Yep. That'll create every error beyond that. Oops. I actually had my normal times for finding naps during the day have been gone this week because I've been driving my older child to college every day because their ankle's broken, which is a story I believe I told last week, and that's a whole thing too because this particular child does not have their ID yet because they turned 18 and during COVID years, etc., etc. But so we've been dealing with the DMV and blah 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 because hospitals see them, regular doctors won't. Blah blah blah. Let's try this. Anyway, so I've been driving them to school every day, and that's an hour round trip, and so I haven't had a whole lot of time for my normal after lunch power nap. Okay, so method not found. Select mini chopper tool. Did I not change the name of the select mini chopper? Oh. Anyway, but I have had some really cool dreams, and one day I had a dream that I was in Mythruna and discovered some features in the engine that I thought were really cool, and I was really ready to tell everybody about them, and then of course I woke up and they didn't actually exist. But look, we got our little button over there. And so, but anyway, so some of them may actually end up showing up because I really liked the idea of it. You know, an aspect of dungeon exploration. Okay, so we got closer. Somebody is setting themselves up poorly. Oh. Yeah, that's right. I never, mini chop tool. Oops. I almost screwed that up. Okay. Whoa. Wrong window. Okay. Yeah, so some of it was kind of cool. The way objects actually kind of falls in line with some of this too, because objects, sub-block objects were in some ways interchangeable with regular blocks, and then some of how that interacts. And I don't know if I can actually make that happen, but for example, there was one dungeon I was in my dream, and I came across this wall that was kind of like partially broken. You could see different, like you could see through it into, you know, through different holes into the tunnel beyond. And I went up and I like shouldered into it, and the whole thing fell over flat like a big slab and then like split up. I'm like, oh, that'd be cool. You come across in the cave like partially blocked, and you just shoulder into it and knock it over, and it just goes down as a slab. That'd be pretty cool. I don't know if I can do it, but it would be pretty cool. Okay, so let's see if this fails. Okay, good. So let's place a block, and let's see if we do this. Yeah, so I get a cursor, and what we want is we want to make that cursor smaller and to show sort of exactly where we're clicking, but we only when we have a block. So let us, we can actually do some really cool stuff. So this will also test our signatures, because what I can do is, you know how this X grid block is a full block, and I'll make it like a quarter block. But I can also use the existing signatures to determine whether I should show that or not based on the shape of the block. So that'll be cool. That'll be like step one of verifying that the signatures are there and getting it all hooked up right, and so on. Oh, we're already half hour in. I barely drank my Pepsi. Apparently I had lots to talk about. Okay, so that's good. Let's go over to the mini chop tool. How does it know? Blocks get empty location, get block location. I see. Yeah. Cool. Alrighty. So what we want to do is we want to call this the micro block. And we want that size to be, these are extents, so I'm going to, that's interesting. Did I make everything in quarter space? Yeah, I must have. That means divided by 4. It's interesting that blocked actually works in, well, I guess it makes sense. In Mythruna, when you're doing a blueprint editor, you know, it takes 4 blocks to make a meter. So, you know, 4 by 4 by 4 is a meter block, which is the same as a cube. And it's not important, but that's the way blockhead was written. So these are actually the full size of a Mythruna block, 1 meter squared. And these little guys, they're actually quarter, so they're 0.25 you know, on the edge. So this should be a teeny little thing now. Yeah, cool. But we want to set it based on, it's interesting that it never, oh, I know why. The remove chopper is actually inside. We want to make sure that our little chopper cursor is always visible, which with JMonkey engine means we do this, set depth right false. Whoops. I think that's all I need to do. I probably want to put it in the translucent bucket just to be sure. I'm surprised I get away with not doing that. Maybe I bet the tool panel is already doing that. So what's that called? Get cursor. Ooh, no, not you. don't want to get too wrapped around the UI stuff, but oh, cursor state set tool, current tool. So let's look up cursor state real quick. For those of you who don't know, in JMonkey Engine, state is kind of a weird thing. There's this, the architecture is built around these app states, which are sort of ways to extend your application to add different behaviors, and they can be added and removed. The whole idea of composition over inheritance. And so each of these is kind of like extending the regular application to give it different features. In this case, it's giving it the little cursor that moves around. And this may be unfortunate because I might not be able to do what I want to do with... I can do what I want to do, but maybe not with the little cursor that I wanted to. It may not be as flexible as I'd like as far as placing the cursor. Because it seems to only change it when the larger shapes get changed. Okay, anyway, I'm getting wrapped around the axle and stuff. Let's, what I wanted to see was who's calling get cursor. Tools, get cursor, set cursor, and set cursor calls this, and nobody is setting the bucket, so I should be able to set the bucket. In JMonkey Engine, the bucket controls what order things render in. There's there are different render buckets, and I can never remember what package it's in, but we want to set it in bucket translucent. But so there's the opaque bucket, which sorts things front to back, because in 3D graphics, if you've painted something really big on the screen, you don't want to paint all the things behind it. And most GPUs are smart enough to know that if I put a little box behind a big box, it shouldn't draw that. And so you don't get any overdraw. And overdraw is very expensive because you just basically wasted time to draw pixels that are going to get covered up. And so then there's the transparent bucket, which that gets sorted back to front, because in order for transparency to work correctly, you have to draw the back one first and then the next one over top of it, and so on. Bucket. Tweak. There we go. That's the ticket. And then there's the there's also like a sky bucket, and there's the translucent bucket. And the translucent bucket gets rendered after everything else and can also be sorted in among post-processing filters and stuff. But it's also a convenient way. If you turn off depth right, or depth test, that's the one I want. You turn off depth test, there you go. Then it will draw itself even if there's already something there, and if you put it in the translucent bucket, then it's drawn last. And so this means we can see it through other objects, long story short. Actually, so I place some things down and I do this. We should be able to see our, whoops. I'm going to get tired of moving that little cursor down. So yeah, now we can see the XXX block even when it's inside of the other block. And it occurs to me, see, that's, I don't know that I'm getting notified. You know what, I'm going to add a debug statement, because I would like to make this pretty, not just because it's pretty, but because it's functional. Like if I know what part I'm clicking on, it'll make the tests better. So it's not just vanity in this case. Alright, so let's see if we really get notified every time that thing moves. Alright, we should be able to test this really quickly. Nice thing is it doesn't take as long to run this as Mythruna, right? Where you can just load it right up, do like this. Oh yeah, like every little teeny movement, that's what I want to see. Nice. Okay. So that means, yeah, I can actually put the cursor right where I want it. Let's see. So it gets the world position. Alright, well we're going to rewrite all this anyway. First of all, we don't need a mini block. We only need the eraser block. Of course, if I get rid of all these things, I'm going to have to put the okay. That's interesting. So I made both of those just, yeah, okay. Whoa, that works. Okay, we don't need a mini block. We only need the eraser block. Oh, this is great. Past me did today me a favor. Let me make sure that I didn't forget something. I did. Oh yeah. Okay, I'm about to get rid of all that stuff. So we still want this. These are telling me from the block state is where all those blocks exist. You know, get me an empty location. So given this world position, this normal, that encapsulates the logic that if I'm on the side of the block, I need to go this way. If I'm on this side of the block, I need to go that way. That kind of thing. We don't really care about the empty location. We only want the block location. And in fact, we want the sub-block location. So we want even smaller granularity than that. But if the eraser loc is null, we don't want to do anything. So we will call this the block loc. So if it has a block location, we'll do that stuff. And I'm just going to comment this out for a second. And so then we know we are on a block, and now we want to find our position within that sub-block. We ought to be able to say, well, this is the problem with being not in the coordinate system that I thought. Since we're already in quarter block size, this is doing math for us, yeah. Get empty location, get world position. Yeah, so this is giving us the world position of that center of the block. Which is why things were showing up in weird places. So what we'll do is we'll say it's interesting that I'm setting the world location of the okay, so anyway, call this base, and this is going to be vec3i, yeah, base equals the world position floor. So this is going to be right at the bottom of the like in a block shape. It's going to be right there in that lower corner. And we want it to be a vec3d, so we'll turn it back. Floor will return a vec3i, which is an integer vector. And I wonder if I can set the cursor position itself. Let's try it. Okay, set Local translation. Base to vector 3f. Okay, so that's going to be on meter boundaries. This can't be right. Oh, but block location is already what I want. So let's try block loc. I don't know if I can do that. Let's just see. Let's see if it lets me. No! Oh, I gotta get rid of all those warnings someday. They make things... Okay. Oh, yeah. Okay, so let's see what that does. Trust me, this is worth another 5 minutes or so to get right. I plan to go longer than 10. I don't know how much longer than 10, but I do plan to go longer than 10. So we have to have some blocks down or this will no longer work because we don't show anything unless we're over a block. Oh no. We don't show anything ever. So the 8 of you are on. That's nice. Again, if you are new to the stream, welcome to the stream. Up in the upper left corner is the link where you can download the January version of the game or join the Discord. It's a super secret link only available to everyone who watches my videos. So I believe that I need to do something different. Let me see what's going on over here again. Okay, so we get the block location. It's going to be in quarter space. Where does loc go? Okay, loc is the empty location. So these are, so these are in cell space. And then we convert those back into world space. Yeah, I see. And so I need to look at what get world position is doing. Yeah, it's basically adding 0.5 and then blocks local to world, which we're already scaled. But I want to do this manually. And blocks is a node. Okay. Do we return it? Block spatial. Yep. Okay. So I can technically, given the world position loc, we just add 0.5 and then we do rescale. Okay. So I ought to be able to I don't know what to call it yet. Blocks that get block spatial, local to world. Sorry, I'm just trying to get my coordinate system straight. I think this will show up now. No, well, I mean, you got to have it. Oh, it needs a. Some of the JMonkey engine methods will automatically. We'll have two versions of the method: one that takes the target and one that doesn't. But that's not apparent. That's apparently not one of them. Okay, so blink. Turn this. All right, we're seeing it. It's just really small, right? And so this is setting it in that lower. You can't tell really, but it's centered on that. We need to add, half. But what I want to do is then add the, well, I'll just do it. You'll see what I'm talking about. So, given the world position and our block location, we ought to be able to subtract. Oh, that's a vector 3f already. Nice. Vector 3f relative equals world position subtract v. Okay. And then, so this is going to look a little weird. Relative dot x equals divided by 4 what is it that I want to do here? I want to say I want to divide it by 4, but I want to then quantize it. I think if I... Yeah, so normally I'd do the... Normally if this was real whole numbers, you would do this, and then you could convert it to an integer, do blah, 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 blah. But what I think I'm going to do is take off the part that's... oh, God. This is the problem with being in like a weird space. What's 2.5 times 2.5? Or 0.25 times 0.25, right? A quarter of a quarter. I want to get it right the first time, so yeah, 0.6. 0.625. I don't need those. So whatever x is, we're going to subtract out the part of it that's not, you know, on the even 0.0625 boundary. And then we actually could have done that right to the world. Then we want to add that back to, before we setting it. Let me make sure I got my math right. Oh my goodness. Oh, I also have to, what is it complaining about? Oh, double, yeah. This is actually going to be a problem. Okay, so YZ, YZ, YZ. And I've now hard-coded a scale, unfortunately. Actually, that may still be wrong. I should have printed the values out to see. Alright, let's see what it's doing. I mean, it's definitely more granular, right? We can see it moving all around. Yeah, but the problem is it jumps around based on, yeah. Well, we can't click inside, that's fine. But we want it to be like, it's, how do I describe what I'm talking about? Yeah, it's not really where it thinks it is. It would just be really convenient if we knew where we were clicking. And I'm just trying to think the best way to do that, and it would be so much easier if this was a meter, but it's 0.25. And then I don't know who's doing the scaling. So when I do that, is it really outside? Or is it half in? That looks like it's fully outside to me. And so if I move over here, yeah. And we're getting a lot of floating point noise as well. Yeah, interesting. All right, what I'm going to do, I'm tired of guessing. So I'm going to put this back in. I should have left it in the first place. And let's see what we're getting when we move those little granular things. And that will tell me what my multipliers need to be, and I can do this in simpler ways. Hard-coded bad ways, but simpler ways. Hard-coded and bad in the sense that if I ever change the scale of what one block means in this tool, I'd completely break my little test tool. Okay, so we are at when we were right on the corner here, we are at, interesting. Okay, so that's y is 0. Okay, so yeah, y is nearly 0.25 because we're almost up to the top there. And yeah, so over here, we're negative 0.5. Interesting. Okay, because yeah, we're off of the 0 axis. Okay, I get it. And then we're almost to the top. So yeah, we are in quarter space. All right. So we're in quarter space. So basically we can just multiply every time thing times 4. We're back to 1. And what I want to do is, so if we imagine, come on. Let's just talk about the math for a second. So this is our block space. And right now what I'm doing is I'm chopping it here and here and here. But based on, yeah, that should have been okay. I was thinking I needed to round to center. But either way, as long as I'm in this range, that's the range I want to click. Well, anyway, we can do this in integers now. And so that makes things a little easier. Or do I want to do, bring up my thing again. So let me think about this. If I'm here, I still want to be in this block. If I'm here, I still want to be in this block. So yeah, it is a floor situation. Oh, but then it'll be backwards when we're negative, if it's not floor. Okay, so what we want to do is, first of all, want to do all this in integer. Relative x times 4 would get us back to regular space. Times 4 again gets us into the sub-block space. Happy Friday, Lando. So if we do this, convert them to integer. Okay. And then multiply them back. So x times 0.625f. 0.0625f y times z times. Okay. Okay, that's basically the equivalent math of what I've done, but I've truncated a lot by doing this. So we truncated a lot of errors by doing that. And I think then we also need to, we're setting the cursor location. The old code set the eraser location. Oh, yes it did. So let's just try that. See what that does differently. So the thing is, these are the actual values I need for indexing into the block shape. So that's a better solution overall. Okay, so let's try it. Oops. Alright, I'm going to put 2 here. Okay, so where are we? Okay, so let me take a look at my values while they're ticking by. We've got this little guy down here. And again, I can't tell whether he's inside or outside because of the certainly seems like it's outside, and it doesn't add up, which is also strange. So here we are. It's interesting. So we're all the way down at 0. As we move up, we're just a little bit up. Yeah, floating point is so bad, guys. See, that's where I believe I want that to be. I think it's based on the normal, actually. We want to subtract, okay. So that way when we're on the surface, like if I'm clicking here, the math is maybe telling me that I'm here, but I really want to be checking here. So this will move me into the block, or I need to subtract it, right? So the normal is like this. Am I subtracting? Yep. So normal is like this. I'm subtracting, a 1/16 of a block. Should improve things. But I don't know why it's not even. Why we get to the top of the block and it's off. Man, we got a lot of viewers. Nice. Assuming YouTube is not lying to me. All right. So let's try this again. Boink. Get wrapped around the axle on these simple things, but okay, so I actually believe we are inside where we're supposed to be. See, we're not supposed to be on the top like that. What I'm going to do for a second is turn off this. I'm going to put depth test back on so that we see when we're inside versus when we're outside, because I think that will, to be honest, normally I would make 2, one that's a different color, shows inside versus outside, and then I might still oops, don't know the controls to my own program. Alright, yeah, so see, we're half in, half out. That makes a lot of sense. Aha. Okay, so yep, because the way the blocks, the way Monkey Engine blocks, they're from the center, and we're treating things from the edge. Yeah, so this all makes a lot more sense. Yeah, so we're not even in the block now. Yeah. Okay, so these are where they're supposed to be. Well, this is not. Oh yeah, it's going to get added. This is positive and this is positive. Or no, this is positive and this is positive. So this is Z. Yep, Z and X. Yep. Okay. So add back the add point. Let's figure out times 0.5. Or wait. 0.2 0.25 divided by 4. Actually, we already had it right. No? This is half. That's good. Copy. Right, so... Now, if I do that, everything's going to disappear, right? Oh, except for they're a little bit bigger than they're supposed to be. So that'll help. Right-row. Okay, let's try again. Oh man, this took me 20 minutes longer than I wanted it to. Okay, come on, we've got to get to good stuff now. You got to work, because I need to get to good stuff now. Okay. It's exactly wrong. This is all right. This is not. This is all right. What I want... Okay, none of this matters, right? But this absolutely does matter. So let's take this out and make sure our X, Y, and Z are right. Because this is what I'm going to use to remove the bits. Subblock. X, Y, Z. These absolutely have to be correct, or we're not going to get any progress. Regardless of where I put the cursor or whatever, we actually have to have those working correctly. So let's move this up here. We'll put a block. I believe that's all positive. We'll see. Oops. Okay. So if we put this down here, 0, 0, 4. 4 is not a valid value, but it is, that's where it's rendering. Okay, 0, 0, 0, sure. 0, 0, 1, 0, 0, 2, 0, 0, 3. Yeah, so the problem is we're just letting it go out. Okay, 0, 0, 0, 1. Okay, so these are all correct over here. Yep, 0 through 3 is what we should be getting. So 0, 0, 0, 0, 0. Okay. What about over here? So this is outside, basically. That's wrong. It's perhaps a rounding error. No. See, again, we're on the top. We shouldn't be. Okay, I need more data. So we get so close. Let's see what relative times 16 is, and let's see what normal is. That, I think, will shed some light. I will tell you that any hour you invest in your tools will pay dividends. So while this feels like it's a slog, this is not wasted time, because the more accurate I get my little tool here, the better off I am. Okay, so we ought to be able to see the problem right here. And so relative, Why though? Zero, 2, 4. We're all good. But like here, yeah, so we, that is weird. Done something wrong somewhere. So this is 3.68, and just moving here, it's like the normal is doing the wrong thing. Because, well, okay, so I need to see what the raw values were, unfortunately. Need to put this back. And, or maybe I can, yeah, no, I need to put that back. And what I want also, oh, this is way too big. Let's take that out of here. I'm going to leave that there for a minute. So that'll give us the world position. So relative to the world, the origin of the block. And then we want to subtract normal x times 0.5 because we're in, we want like a half block version. Actually does not matter, but I do need to put this all in the int. Alright, let's try this. What I want is that little X block to hug the edge of the block I'm clicking on. Not just on one side, but all the sides. Because when we looked at it, it wasn't just a problem with where the cursor was being drawn. It was actually a problem with our XYZ values. And so, ta-da! Alright. This is what we want. So everything is going to still be in that 0 to 3 range. Occasionally we get out. Oh, we only get out because the floor lets us do that. Okay. So, neat. Okay, so now we can chop things away and see what happens. All right. Yeah. So then I ought to be able to also debug to make sure that these are really set. Yeah. Okay, we got stuff working now. All right, ladies and gentlemen. We're getting closer. Now, we need to somehow get the collider crap over here. And I don't think we even depend on that. Yeah. So we need more dependencies. More. Sim mblock fizb. I think. mblock fizb. Yep. Fizb. Okay. Up until now, the blockhead tool has not needed access to the physics stuff, but now we want to be able to build the colliders and so we know how to build the thingamajigget. New collider factories create colliders. Okay, cool. Colliders. I think we'll just build this right into the mini chop tool. Oops. Fail fast. Fail hard, fail fast. Yep, you can't change the... Okay, colliders. And I think... Fizz. I think I just need fizz. Fizz and collision. Let's go ahead and take them both, just in case. Thing about not using a fancy IDE is it won't do those for me automatically. Oops. Stop it. Okay, we want to signature collider utils. Okay, so if we have a block, how do we get the block? We have a block location. Let me log the block location. And I think from the block state we can get what the current one is. Yeah, get cells. I was looking right at it. So int cell equals blocks dot get cells dot get cell array. Is it get value or get cell? I'm thinking it's get cell. Yep, with the default value. Get cell block loc dot x dot y and dot z and cell is less than -1. Return null means we're not really in the block space. Log info cell. Int type equals mask utils that get type cell. In Mythruna, actually in the Moss block world stuff, the mblock stuff, the lower 16 bits have the actual type of the object. I think it's 16 bits. The upper 16 bits have like certain kinds of data about the sides that are visible, which way light can propagate and stuff like that. So to get the actual block type, you have to do this. And so type, and we ought to say block type, just to see block type index get type. See what happens, just to be sure. Oh no, I was in the wrong window. There we go. Oh, got to import the right things. Oh. Ooh. Baby gummy. Oh my goodness. Yes, of course. The block type index get types. Get types. It's always fun. The thing about when we did AI for like 3 weeks in a row, I got really familiar with the code again, and I knew where things were intuitively, and I haven't used the mblock code in a long time. Okay, so I did something wrong. It's like complaining about lots of stuff. Whoa. Okay. Implements tool. Cannot find symbol. Oh, I apparently took out the yeah, okay, so I still need blockhead to get the root level stuff. Hey, we're gonna run this time. Yay. Ba-ba-da-ba-da-ba-da-ba-da. Yeah, I mean, even if we weren't continuing on the live stream, I've already got a significant head start on what I'll be doing this weekend. Oh, this is not good. It's doing the opposite of what I want. Rut row. What's it telling me? Yeah, so those are all -1. I should be... Oh. Didn't I say if it's -1? Oh, if it's less than -1. I'm a big dummy. But still, okay. Let's fix that and try again. All right. Lasai. Lowo. Lasai. Okay. In the block editor that the older version that was for my kids, it remembered the last thing you had loaded, which was kind of nice. So 20019 is the block location, but apparently it thinks there's no block there. Maybe there's some other translation that happens, because those are definitely their block locations. I mean, if we looked back, we've got 10 or 8, 16, 20. Yeah. So this would be 1919 here. This is 2019. So that's correct. 2019 0 should have a block there. But for some reason we are not seeing a block there. Did I do something wrong here? Block X, block Y, block Z. So in the block state, when I set something, is this where I set it? Set block loc. So it's a loc XYZ. In fact, I've got a convenience method I could have called. Let's do that. So instead of calling this, I could have called blocks that get type, right? Is that what it was? Oh, get block. So that should have given me a cell value. But why it not? Why it not give me that? I got to know what block I'm on in order to take things away from it. That is absolutely critical. Okay, so let's do this. Boink. Aha. Oh. Yeah, because of the it needs to be exactly not -1. Anyway, because of it actually is getting the block, but because of the masking, things go negative. So you can't just say less than 0. In fact, this is not where we want. We want that's not going to work either. What we can do though is, yeah, what we should do, if it is, if it also is, or type is greater than, oops, block type index get types length. There is actually a get nums type, but I don't remember what the name is. I don't feel like looking it up. Okay, so if it's outside the range. Okay, so now we should be able to see the block type. One step at a time, right? Oh, and me cannot type. Okay. All right. So, I think we need to make it so we get 0 when there's nothing. 0 is the one case where we'll never have bits set. So we want to bypass this. We want to go back to this. Oops. And instead of returning -1 when we're out of bounds, we're going to return 0. And so if the type is in range at all, type will always be in range. It should never not be in range. And it will sometimes return null, but that's fine. Okay, so we should always get a block even if it's null. And let's give it a try. 0 is the one value you can guarantee doesn't have any masks set, and it's never a block type. The way the index is set up, 0 is always not a block. It's empty space. So that's what I should have really been using. Okay, so see we got a block type, now we got no block type. Okay, it's going to take it a second to catch up. Yep, so see we got no block type here, but now we've got a block type. Yep, okay. Cool. Okay, so then if we've got colliders, we know what type we are. If we don't want to print all that stuff out anymore. If we don't have a collider for this type, then we don't need to do anything. Hopefully that doesn't come back to bite me. And then now we can use the collider utils. Where'd it go? Way up here. Collider utils. calculate a shape signature. Collider utils, shape signature, shape signature, sig equals collider utils. Okay, so we want, well, let's, the collider for this typical, for this particular type of block, probe radius is 1.25 because it's half of a quarter. So our little spheres are full quarter in diameter. Okay, so we ought to be able to log info the signature, and we ought to be able to log info is set, sig is set xyz, and if not sig is set, return null. So now if we had a subblock, well, let me show you what I'm talking about. So I'll put that, let's make sure I'm not speaking out of my butt. Okay, whoop. Just 7 Mythruna nerds hanging out on a Friday night. I really appreciate it, guys. This is a lot of fun for me. Especially, it's nice to hang out with like-minded folks after spending all week doing boring stuff. Okay, so we got that guy. Yeah, so he's a block. Now, let's pick a different, was it base one that had wedges? Okay, so we got a wedge. Oh, gotta put the wedge there. Oh no, base one wedge, okay. Okay, so let's put this over here, and alright, now if I go back over here, it's going to show me a different signature, right? And it's going to show, well actually, it's already doing what I wanted it to do because of the way the colliders work, so so all those are going to be set. Is set true, is set true, is set true, because I can't actually mouse over the middle parts. Okay, so we know all those are set, we know all these are set, but what I want to do is when I click this guy, like if I were to left click this guy, yeah, right? I want to use the signature to find a similar block, and then I want to replace this one. So let's do that. Although I'll have to start using a different block type now. We'll use the all blocks. Okay, so this is just a safety precaution. We already saw that it's not letting us select the parts of the shape that aren't real anyway. But that's basically saying if the signature already doesn't have that section set, just return, don't even show the cursor. So we got our cursor where we want it. Let me grep and see if we even saw alternate. Okay, alternate's placing, it's main that's removing. So we don't actually care about this. We want to see main. And essentially, we have to do all of this calculation we just did up here. So, did it give us everything we need? Yes. We can get existing. We can do this. But we don't need to display any of it. So we got... Oh, it doesn't tell me the block loc. Oh, I got it from here. Okay, so I got to do that too. So we get the block loc if we just return there's no null. Okay, we get the cell. That's the cell. We get the type. If we don't have a collider for it, nothing we can do about it. Okay, we get the signature. We don't need to do anything special. We get the XYZ, which we've already confirmed is right. And now what we want to do is we want to take signature, shape signature. Shape signature find equals sig clone. Okay, so we're going to make a copy of it. We don't want to wreck the original. Although it doesn't really matter here because we're calculating it on the fly. Eventually this is going to be code in an index somewhere, and we're going to be reusing these signatures. So we want to find, and we want to unset XYZ. And then what we want to do is find a shape that is similar. And I started writing an index, similar shape index, and I didn't actually put anything in it yet, but let's hook it up. So we want to have a similar shape index. And so this will keep track of the block types, like what their base shape is, or base material, so it'll only find blocks within that material. New similar shape index types colliders. Okay, and then what we want to do is we want to say, given that I know that it's a certain type, find me. This isn't going to be helpful, but we're going to do it that way anyway. I'm going to call it shape index. Find similar. And eventually I'll build an index, like an actual index, so I won't have to like search every time, but we're going to search every time today. And so we want to know the current type, which is and it could be that the most similar, okay, well this is something we're going to have to deal with. So, okay, block type get and signature. Let me do something else. Block type equals every now and then I hear like loud thumps coming from elsewhere in the house. That's because like I said, my adult child had broke their foot, and so hobbling around on crutches. Alright, block type dot get name new type. So what we want is, okay, so we're going to log info new type get name. So we're just going to see how that's working first before I go searching through the list to find it. We're going to implement this method. And this is a little tricky. We want to make sure not to return. Maybe I do pass the block name in, so I can make sure not to return the same type. There it is. I'm like thinking and hunting at the same time, which is always fun. Okay, so block type find similar to this one with this signature. Oh, sorry, I needed to stretch my neck. The weight of the headphones is bearing down on my shoulders. Okay. All right, so we know. We want to find the best one that isn't us. So, you know, if I had included the index in here, I could have returned the index. That is mostly more useful to callers. So we want to set the shape entry, and then I can actually return the int type. So we'll have to fix our code over there, but this will work. So int best. We want to find the best index, and we want to so keep track of the best best count. Okay, best count is 0. So then we will go through all of the shape entries that are in our shape index for that type's name. Because I built a multi-map of basically a string key. Oh, get name, get base. Oh, hopefully it has one. If type equals null, or type dot get name equals null, return 0. Okay. All right. So we go through. Basically, as I went through all of the shapes, I built shape entries for them and put a list of them associated with the base name, which is the for a given shape. When it says like wood, cube, or whatever, the base is the wood part. So we're going to go through all the entries for the same material. And what we want to do is test. So let's do long test bits, sig get bits. Eventually I'm going to move this logic into signature, but for here it'll be interesting to see the math as it works out. So we've got a bit string for which blocks are on and off in that 4x4x4 grid. Entry, signature, and so that's the desired bits we want, and these are the bits of this particular shape. And so let's say you have some bits that look like 1 0 0 1 1 1 1 0 1 1 0 1 0 1 1 0 1 1 0, and you have some other bits that are like something like that, right? So this is our test, this is our shape, maybe something like that. So if you AND those together, and logic, bitwise AND, you get only the values that are the same in both. So then it would be like 1 0 0 0 0 0 1 0 0 0 1 0 0 0 1 1 1 0 0 0 1 1 0, right? So those are the bits that are common. And so if you think about this as all the blocks in that 4x4 space that are on and off, this is all the blocks of that 4x4 space that are on and off. And so this is all of the blocks that both of them have on. All of those ones are all the blocks that both of them have want. And so if we could count these ones, 1 2 3 4 5 6 7 8, we know how much in common these two guys have. There's actually a convenient function for counting the number of ones in a binary number. Surprisingly, it's very convenient. So int count equals long bit count. But first we're going to combine them. Is bits and test bits. So those are the logical combination. And I'm going to be smart. I'm going to do some logging in here, checking entry type. Well, yes. Entry type get name. Let's do log info find similar. We'll just hedge our bets, right? That this is not going to go well the first time. And sig. Okay. Checking entry. Oops. Sig entry dot signature. Okay. Signature. Okay. All right. So we got the combined ones. Let's do a little indenting. Log info combined. Long to binary string combined. Okay, so we're doing all the logging. Combined. If that count. Okay, so we also want to think max count is the long bit count of our test bits. We never want to have more bits when we're done than we started. So if count is greater than max count, continue. We don't want no, that is not the one. This is the one I want to check. Long bit count bits. If this particular block has more on than us, that is not necessarily the best check. Alright, I'm going to leave this out for now because I think it gets tricky. So if count is greater than best count, then we found something more similar than what we found before. And the best index is the entry index. And the best count, oops, equals count. Right? So we found a better one than any previous loop. And then when we're done, we can return best index. Can actually log similarity count. Okay. Now we got to fix our other code. I did not forget. I almost did. Where'd it go? It is right here. Mini chop tool. So this is int. Hey Paul. Pretty good. How are you? Hanging out in the almost 2 hours into my live stream. I'm hoping that I have like a breakthrough here in a second. Block type block type index get new type index. Okay, let's see. Glad to hear it. Uh-oh. Mini chop tool. No return nulls here. Cut and paste coding for the win. Come on, show me something significant. Okay, so we need to pick a type that's got everything. So I'm going to find the all type because all, even though they're ugly, they have all of the shapes. Actually, let's start with something that's easier to debug, right? We've got a cube and a wedge, so this is an easier one to debug. All right, so let's go to our chopping tool. And so we've got a full thing. It's going to return the same block because I'm not... oh, it won't. Oh, it will because I don't... Anyway, it's going to return the same block, isn't it? Yeah, so... we started out with base 1 cube, and then we ended up with base 1 cube. Yeah, because of that max size thing I didn't put in, we need to make sure that we skip at least the block type we were passed. Where is it? There it is. So if entry type equals type, continue. So we won't ever return the same one we passed in. Okay. Do 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 do. I kind of miss the fact that when we play Mythruna all the time, we get a little bit of theme music every time. I kind of miss that. Maybe I have to add some theme music to my tools. I think I got thump thump thumping going downstairs. Okay, so if we click here, should end up with a wedge. Yep. Okay. Alrighty. Yay. So let me actually do something with this value, and then we can start playing around with whether this algorithm's actually working. Basically, we will know if yeah, we'll know if this is going to work, I think, in a second, or if it's got promise. So I think we can just say set block, blocks, set block, the location, block loc. Right. Yep. Set block loc new type index. So that means it could actually end up completely removing the particular block we're trying to edit. But that's actually desirable in my case. Like once you've removed enough blocks that there is no more shape, then that's when you've fully destroyed the block, and you'll get the rest of the stuff kind of exploding out. Okay, so let's place a few of these down. We're going to zoom in and delete different parts of them and see what happens. Okay, so we're going to delete this part over here. Boink. Oh, look at that. Okay, we're going to delete this part over here. Boink. Ah, that's not right. Bastards. Uh-oh. It's returning the same one every time. That's not right. Oh, What happens if I click them again? Oh! It put it back. All right, there's still some stuff to work out. Okay, so let's take a look at our logging. Okay, so I need these two signatures to line up because I think that please keep this feature. Yeah, so here's the problem, right? Okay, checking base cube. Yeah, we don't want to check base cube, so that's fine. But no, the signature is wrong. The signature we're passing in is wrong. Because it should have had one fewer. There should have been a 0 in here somewhere. Okay, so something's wrong. Not here. Let me see. We passed in the sig. Test bits. We're finding the sig. Find similar is showing the wrong thing. So did I pass in the wrong one? That's just the kind of dumb thing I would do. Yep, I did. We want to find that. So basically we were passing in a full cube to try to find a full cube, and then we weren't returning a full cube because we specifically don't return a full cube, but we were never going to find a better shape than that. So we're going to keep toggling back and forth between best and worst match. Alright, let's try this again. Scatter some things around. Move in. Grab X. Okay, so let's try one of the ones that wouldn't work before. Doink. Aha! So doink. Okay, so that's going to happen. Yeah, so the thing is, it doesn't know better than... Yeah. Sorry, it doesn't know that one wedge is better than another. Right, if I click here, it's going to find this one first. Even though, like, logically, that doesn't make any sense. Yeah, so that one will find that. If you click the right, if you click the correct corner, it will find something that... but we're getting closer. So let's go back to our tool here. Let's do the all and place a cube, a couple cubes here. Okay, so now let's see what happens if I click here. Ooh, that's interesting. Uh-oh. Yeah, it shouldn't find the spheres, unfortunately. Ruh-roh. Yeah, so that's a problem. So again, this is an experiment. And this is where I need to put... Well, the thing is, the cylinders are wrong anyway because they include... they include the... they basically look like a full block because of how the signatures are calculated. So I need to skip cylinders specifically because they're going to require special handling. And so... What is the best way to do that? I think if we look in here... What are the cylinder shapes? I think they start with... Okay, so V-cyl. And H-cyl probably is what I wanted to skip. So we're going to hack in some stuff to try to get this looking a little bit better before I cut off for the night. So if entry.type.getName is it shape name? Block name. Nope, just get shape. Okay. So I'm going to check for a couple things. So we're going to shape. Oh. Okay, so if, well, we'll just do, yeah, if shape starts with V-cyl. Oh wait, actually we only care about the, well, all cylinders need to be handled specially, so we'll do it this way. V-cyl, skip it. And if it starts with horizontal cylinder, I don't think I have any in this, but just in case, because they'll have the same problem. I'll show you what I mean. Get type, get name. Let me show you what I mean for a second. Uh-oh, we're onto water. I wonder what my longest live stream is. So if I switch here to yeah, so this is a more painful version. So what I'm talking about, yeah, so H-cyl, you see it ticks all of the blue, every every collider hits because it's enough filled. Cylinders have to be handled special. Because also there's no sub blocks that could be used for cylinders. Where's my V cylinder? Maybe I didn't. There it is. So similar here, right? They sort them all. Of course, now the smaller V cylinder is fine. It just picks the center. But I don't want to ever select a cylinder. They're going to have to be special cased, where I'm going to treat cylinders differently and basically warp their space so that they feel like a cube. But anyway, I'm going to warp the space of cylinders. That's the plan anyway, so that when you chop a tree, you get little chunks out and stuff. So let's go back to our other thing that we were checking and see if we get better behavior. I just have a feeling I'm not going to be happy with the experiment, but we'll see. I may have to put an artistic index in, but we'll see. That's why we test things, because I've thought that many times, and it turned out that the prototype did better than I thought it would. Okay, so let's click off this and see what happens. Oh! How did you get to be best? We need to skip cones too. Spikes. We need to skip spikes. We need to skip... What do I call them? Cones? I should have looked while I was in the tool. In fact, I will. It's just easier to search in this particular tool because it sorts them by type, like in Mythruna. So if we come here, we select all, then I can see all of the shapes. Oh, the other thing I can do is I can place this, and I click the X on the corner, it'll turn it into a spike, and I should be able to go back over here and hit C to select that. Like, yep. So that's cone. Cone down. Cone down points up. That's weird. Okay. So cone and spike. I need to skip cone and spike. And I'm putting these on different lines because. Alright. Let's see what's going to fail this time. There's some bit math I may have to do that's a little more complicated than what I'm doing to find the best shapes. I may have to come up with 2x2x2 signatures as well as 4x4x4 signatures, and then do some kind of combination of the comparisons. But let's see what happens now if I click this. Okay. Okay, but see, these are bad because they already show up as full blocks. So that's the same problem. What I want to do, I can fix this problem by putting this in. Basically, we will never pick something that has more bits than what we already had. Right. I think that will limit the problem space. Maybe too much? Or the search space, but we'll see. But basically now it will never return a full cube, because it can never have more bits than when we click here, we're giving it a full cube minus that little square, so it'll never let us return more bits than that, so it can never get better than a cube. Okay. Okay, so these wedges, so that's actually right. So if I click here, it should give me the rest of the wedge. Ah, check it out. So if I click here, yeah, check it. Whoa, boy. What happens if I click here? Oh, check it out. It's not great, but oh, check it out. I'm okay with that. Um, and so then if I click here, it just goes, yeah, it'll just, checked exceptions suck. um, so that's working. That's kind of cool. Let's see if I can get a vertical spike, vertical post. Yeah, it's a little squishy, but I think I'm okay with that. I think I want to see how far I can get with that, especially considering that we're going to be using it for chopping up larger blocks. Like what we're really going to be using it for, is chopping into one of these guys and making the little blocks. And I think it's okay maybe then if they're a little squishy and that I call them squishy because they're squirming around underneath what you're clicking, right? Like if we click here, we're going to get that. If we click here, we're going to get that. But if we click here, it puts stuff back. But I kind of think if you're chopping into rock, and this is just one of a 4x4x4 block, I think that's probably okay. Yeah, so that's going to crash if I call it again. But what happens if we click down here? Check it out. And if we click here, it should give us a half wall. No. That is incorrect. But there it goes. So there's some bit finagling to do. But so far, hey, check that out. I'm pretty happy. So if I click this, it should give me a beam. Yep. Ha 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 ha. Nice. So what happens if I click in the middle? Yeah, that's okay. Wedge. What happens if I click over here? Okay, from a raw bit count perspective. Yeah. So then there's there's a check I can make to make sure it doesn't put any bits back. But I don't think that's going to help here. So if I get rid of this, should it? Yeah. So there's if I add the bit that I toggled to the search, meaning, we're searching, like we're comparing this bit stream against this bit stream, but like we make a requirement that no matter what, don't turn back on the bit that I just said should be off. Yeah, these are the palette textures. So like this is the same. Yeah, this is in the regular blockhead tool. These were all the colors that were available. It's just a convenient texture for testing things because you can see exactly where textures start and stop, and so when you're trying to get your textures to line up on the wedges correctly, this was a really good test pattern. Anyway, what I want to do is make it so that if I click this part of the square, no matter what shape it picks, that particular block will not be on. It will find the best shape that doesn't have that on, whereas right now it's picking different things sometimes and leaving it on. So if I click in the middle bottom here, yeah, so see, count wise this was okay, but it didn't actually remove that block, even though it improved the counts. It found a block that matched mostly, so I think that will help. Check that out. Whoops. So yeah, so this is like when we're chopping, chop 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 chop. Whoa, no. Yeah, we found a bunch of blocks that didn't work, but that's what we're going for. And so I think I'm on the right track. I will spend the whole weekend messing with this, and maybe put together a video for Monday if I get something really cool working. Otherwise, you guys can check out the next live stream. Does anybody have any final questions before I wrap it up? Otherwise, I'm going to search for my little thing here and bring up the thanks screen. Thanks for hanging out for over 2 hours, you guys. That's awesome. And so you must like it. So just go down and click the like button. You stayed. If you have something to comment on, that'd be awesome too. If you want to ask some questions you think of after the video, or if you are watching this not live and would like to ask questions, just add a comment to the video. I respond to everything that I see because I don't get enough traffic to be able to ignore any of it. So If you ask a question, I will respond. I don't know. We may have just made the stream record. I don't know if I've ever done a 2 hour and 15 minute stream before. Yeah, I'm glad you could make it too. So, yeah, I actually find these more productive than I thought they were. My voice is always shot right after, so I think we're going to keep doing long live streams as long as I can cope with that. But thank you guys so much for joining, and I will catch you on Discord, on Twitter, and on Blue Sky, which I hope to start using a lot more because I like Blue Sky. But Discord's cool. You guys hang out on Discord, comment on the video, and I will see you guys next week. Same bat time, same bat channel, etc. So thanks so much.